Hello everyone, welcome back. So, in the previous videos, we have seen how to solve bisection methods. So, now let us learn regular-falsi method. Okay, so the regular-falsi method is considered to be one of the oldest methods for finding the roots. Okay, so by now we should be good with bisection method. If we are, then I think this would be very easy for us to learn. If not, I would suggest to first go with those videos, practice them and then come back to this. So let's solve question number 1 using regular-falsi method. It is find the root of x cube plus x minus 1 by regular-falsi method. Correcting to 3 decimals is the question. So what did we do in the bisection method? We used to find two numbers a and b such that f of a into f of b will be less than 0, right? Even in the regular-falsi method, we will have to do the same. We have to find two numbers a and b such that f of a into f of b is less than 0. Okay, what is our f of x? F of x is x cube plus x minus 1. What is f of 0? Substituting 0, it's minus 1. And what is f of 1? It's substituting 1, right? We get answer as 1. So f of 0 is minus 1 and f of 1 is 1, right? So our f of 0 is less than 0 and f of 1 is greater than 0. So what can we say? F of 0 into f of 1 is less than 0, right? F of 0 is minus 1 into f of 1 is 1. So minus 1 into 1 is minus 1. Minus 1 is less than 0. Okay. So we have got two numbers such that f of those two numbers, so f of 0 into f of 1 is less than 0. That means what? Root lies between 0 and 1. Okay. So now let's go back to the table. So in the table our first column would be I, which is iterations, and next would be interval. So now we got the interval as 0 and 1, correct? Root lies between 0 and 1. Our next column would be xi. So in bisection method, what was our xi? Yeah, right. In bisection method, the xi is a plus b by 2. So in regular-falsi method, our xi would be a into f of b minus b into f of a by f of b minus f of a. Okay, so here I is iteration and then next column is interval, and our xi in bisection, if you think about it, it is a plus b by 2. In regular-falsi method, it is a into f of b minus b into f of a by f of b minus f of a. And our next column would be f of xi. So whatever value we get xi, we find the f of x for it. So f of xi would be x cube plus x minus 1, right? So I'll just put I. In each iteration we'll find that. Okay. So this is about our table. Now in the first iteration, our interval is 0 and 1, right? The root lies between 0, 1. So 0 and 1. So this is A, this is B. So 0 was giving us less than 0, 1 was giving us greater than 0. Okay. So now let's find out x1. First iteration, no? So I is 1, x1. Let's substitute the values. A is 0, a into f of b. F of b is f of 1 minus b into f of a. b is 1, f of 0 divided by f of b minus f of a. It's f of 1 minus f of 0. Okay. So x1 is equal to 0 into f of 1 is 0 minus 1 into f of 0 is minus 1, right? So it's minus 1 divided by, oh, something has happened. Okay, So divided by f of 1 is nothing but 1. So f of 1 is 1 minus f of 0 is minus 1. Right? F of 0 is minus 1. I have substituted. So what are we going to get? This is 1 divided by 1 plus or 1 minus of minus 1 is 1 plus 1, which is 2. This is 0.5. So x1 is 0.5. Now we'll find out f of 0.5. F of 0.5 is nothing but minus 0.375. Just substitute 0.5 here, 0.5 whole cube plus 0.5 minus 1. We are getting minus 0.375, which is less than 0. Okay, so when we get something less than 0, what we have to do in the next iteration? We did the same in bisection method also. So what we should do is, in the second step, so since this is less than 0, so this value we should always take. Whatever we are getting x1, x2, that we will take in the next interval. Along with it, since this is giving us less than 0, we will take greater than 0 from the previous interval. Okay, so this is 0.5, x1 0.5 is giving us less than 0. So here less than 0 was 0 in the previous interval. So instead of 0, we will write 0.5. Okay, because 0.5 is also giving us less than 0, comma 1. So now root lies between 0.5 and 1. So this is less than 0, this is greater than 0. Now this is A, this is B. Now let us substitute the values and find out x2. Now x2 is equal to same, A into f of B. A is 0.5, right? So 0.5 into f of 1 minus 1 into f of 0.5 divided by f of 1 minus f of 0.5. So what answer we are getting? We are getting 0.636. Now what is f of 0.636? It is nothing but minus 0.107, which is again less than 0. Since this is less than 0, from the previous interval what was less than 0, we will replace that with this new x value. Okay, so next I should not have drawn the lines, they are looking ugly, but anyways, so 0.636 comma 1. So this gives us less than 0, this gives us greater than 0, right? So x3 is now 0.636 into f of 1 minus 1 into f of 0.636 divided by f of 1 minus f of 0.636. So here we are getting, what are we getting here? Here we are getting 0.671. Now what is f of 0.671? F of 0.671 is minus 0.027, which is less than 0. So again this is giving us less than 0. So previously what was less than 0, we will replace that with a new x value. So in the previous interval this was less than 0, right? So instead of 0.636, I'll replace 0.671 comma 1. Again this is less than 0, this is greater than 0. So root lies now between these two numbers. Now let's find out x4. Now x4 is equal to 0.671 into f of 1 minus 1 into f of 0.671 divided by f of 1 minus f of 0.671, which is equal to 0.680. So now let's find out f of 0.680. F of 0.680 is minus 0.006, which is again less than 0. So we are going to replace 0.671 with what? 0.680. Now fifth iteration, it's 0.680 comma 1. So this was less than 0, this is greater than 0. Now x5 is 0.680 into f of 1 minus 1 into f of 0.680 divided by f of 1 minus f of 0.680, which is equal to 0.682. Now f of 0.682 is equal to minus 0.001, which is less than 0. So again, since this is less than 0, in the previous interval what was less than 0, we'll replace that with a new x value. So in sixth iteration, it's 0.682 comma 1. Now x6 is 0.682 into f of 1 minus 1 into f of 0.682 divided by f of 1 minus f of 0.682, which is nothing but 0.682 again. So we are again getting 0.682. So we don't have to find this again. So since our x values are repeating, okay, we can say that this is the root correcting to 3 decimal places. So we can say root of x cube plus x minus 1 is 0.682. Okay, so let's solve question number 2. Question number 2 is find root of 4 e power minus x sin x minus 1 equal to 0 by RegulaFalsi method given that root lies between 0 and 0.5, correct to 3 decimals. So here they have only given the interval, okay, they only gave the values of a and b. So I don't think we have so much more to find out what is the value of a and what is the value of b, because they have already given. Okay, so our f of x is equal to 4 e power minus x sin x minus 1. So what is f of 0? F of 0 is minus 1, and substituting 0 in place of x, 4 e power minus 0 sin 0 minus 1 is minus 1. This is less than 0. Now what is f of 0.5? It's 0.163. This is greater than 0. So root lies between 0 and 1. Sorry, 0 and 0.5. I got used to writing 0 and 1. 0 and 0.5. So root lies between 0 and 0.5. Now let's start our table for RegulaFalsi method. So first column is I, iterations. Next column is interval a comma b, and next column is xi. How do we find out xi in RegulaFalsi method? A f of b minus b f of a by f of b minus f of a, and then in the end we have f of xi, which is 4 e power minus xi sin xi minus 1. So let's start. The first iteration. We know that the interval is 0 and 0.5. Okay, 0, comma 0.5 is our first interval. Let's find out x1. So this is A, this is B. So A is giving us less than 0, right? F of 0 is less than 0. B is greater than 0. So far it is clear. Now let's find out F1. So x1 is equal to 0 into f of 0.5 minus 0.5 into f of 0 divided by f of 0.5 minus f of 0, which is equal to 0.430. F of 0.430 is equal to 0.085, which is greater than 0, right? First we found out x1 value, we got 0.430. Now let's see what is f of x1. So f of 0.430 is 0.085, which is greater than 0. So since this is greater than 0, in the previous interval what we had greater than 0? 0.5, right? We will replace that with new x value. So now second is 0, 0.085. So this is A now, this is B, this is giving us less than 0, this is giving us greater than 0. Now x2. x2 is equal to 0 into f of 0.430 minus 0.430 into f of 0 divided by f of 0.430 minus f of 0. So the answer is 0.396. Okay, now let's see if this gives us greater than 0 or less than 0. F of 0.396 is 0.038, which is greater than 0. So in the previous interval, whatever was greater than 0, we are going to replace that with our new x value. So in third iteration, we have 0, previous iteration 0.085 was greater than 0, right? So we are going to replace that with new x value 0.396. If this was giving us less than 0, then we would have replaced 0 with it, because in previous iteration that was giving us less than 0. Now this is A, this is B, this is less than 0, this is greater than 0. Now x3 is equal to 0 into f of 0.396 minus 0.396 into f of 0 divided by f of 0.396 minus f of 0, which is equal to 0.382. Now f of 0.382 is equal to 0.018, which is greater than 0 again. So we are going to replace whatever was greater than 0 in previous interval with our new x value. So fourth iteration 0, 0.382. So this is our A, this is our B. This gives us less than 0, this is giving us greater than 0. Now let's find out x4. x4 is equal to 0 into f of 0.382 minus 0.382 into f of 0 divided by f of 0.382 minus f of 0. So this is equal to 0.375. Now f of 0.375 is 0.007, which is again greater than 0. So since that is greater than 0, we are going to replace it with whatever was greater than 0 in the previous interval, right? So fifth iteration 0, 0.375. So this is A, this is B. This is less than 0, this is greater than 0. So x5 is equal to 0 into f of 0.375 minus 0.375 into f of 0 divided by f of 0.375 minus f of 0, which is equal to 0.372. Now f of 0.372 is equal to 0.02. It's 0.002 actually, greater than 0. So this is also greater than 0. So now we will replace whatever was greater than 0 in the previous interval. Now we'll replace with a new x value. So since this is greater than 0, in previous interval whatever was less than 0 we will write as it is. Okay, 6. In 6th iteration 0, 0.372. This is A, this is B. This was less than 0, this was greater than 0. Now x6 is 0 into f of 0.372 minus 0.372 into f of 0 divided by f of 0.372 minus f of 0, which is equal to 0.371. Now f of 0.371 is equal to 0.001, which is again greater than 0. Now in our next iteration, 7th iteration, so since this is greater than 0, so we are going to replace it with whatever was greater than 0 in our previous interval. So 0, 0.371. Okay, this is A, this is B, this was giving us less than 0, this was giving us greater than 0. Now x7 is 0 into f of 0.371 minus 0.371 into f of 0 divided by f of 0.371 minus f of 0, which is equal to 0.371 again. So we are getting the repeated values of x, right? So x6 is approximately equal to x7. So we can say that the root is 0.371 rounded to 3 decimals. Either if this value was almost becoming 0, if f of whatever x we have, right, if f of x is becoming 0 approximately, then also we can say that that particular x is our root. Or if we are feeling that the roots are repeated, then also we can say that this is our root. So these are few examples of how to solve the questions using regular falsi method. So I did not go into the depth of how to replace the values in the interval and all, because it was more clear in bisection method already, and it's the same thing. So the only difference is we have to replace, or we have to change how we calculate the value of x. In bisection method we calculate x as a plus b by 2, whereas in regular falsi method the x is calculated as a into f of b minus b into f of a by f of b minus f of a. So in the next video, let's see few more questions on regular falsi method. Thank you. Please subscribe if you find this helpful.